Covered mapping binary relationships. We will talk about mapping unary relationships, mapping ternary relationships, as well as mapping subtype supertype relationships. We'll start with mapping unary relationships, which are called recursive relationships. And the cases that we are going to cover are one-to-many and many-to-many unary relationships. So let's start with the one-to-many unary relationship. And we have this example where we have an employee that manages 0 or more employees, and each employee is managed by 0 or 1 employee. And the rule says we will have a recursive foreign key in the relation. And what we mean by this is the manager ID in here, which is a foreign key, is the same key that is used in the relation as employee ID. Now let's see if this is going to work in real life and why do we need to have a foreign key. So let me have the first column representing employee ID. I will not talk about these two because this and this are what's gonna matter. So supposing that employee 001 is the manager, that employee is not managed by anybody because remember we said it's an optional. So this is going to be null for manager ID. This works just fine. Now employee 002 is managed by employee 001. And the ID right here is the same ID right here, so this is fine, so we are still good. This is the primary key, and we don't have any repetition so far, so we don't have any problem inserting the data. 003 is managed by 001 as well, and this complies to this, and we don't have any problem, so it still works. 004 is managed by 002. This complies to this data, so we are fine. 005, if we say, is managed by 006. Now if we look here, the 006 is not in the set of primary keys, and this is a foreign key, and we said for the role of a foreign key it has to have a primary key that it's referencing. Since we don't have an employee 006, then this cannot be inserted, and this is what's happening right here, and that is why we need to have it as a foreign key. Now let's look at the other case, which is the unary many-to-many relationship. So in mapping this type of relationship, we will need to create two relations, one of them to represent the entity type and one of them to represent the relationship. So now you have seen some kind of a trend here where every time we have a many-to-many relationship, we will have to create a new entity, or I mean a new relation. So anytime you have a many-to-many, this will result in a new table or a new relation. So let's look at this example. We have an item that contains multiple items. So an item contains 0 or more items. So for example, if I say a mobile phone contains a screen, contains a processor, contains an antenna, contains speakers, and so on. And if I look at the processor, it will contain some parts like registers and so on. And for the screen, it might contain, like, let's say, the touch ID something, so the touch recognition or some face recognition. So this is what this example is saying. And then I need to know the quantity. So for the phone, how many speakers do I have, and how many antennas, how many processors, how many screens, and so on. Now let's look at how we map it. We said we'll create two entities or two relations, one for the entity type and one for the relationship. Now we have the item here, we mapped it as it is, and then we have one for the relationship. Now the one for the relationship will have the primary key based on the entity. Now, why do I have component number and item number both referring to the item here, and I have quantity? Let's try to map it, or let's try to fill some data, and let's try to do another mapping and see. So if I say, okay, I have the item which is a phone, which is, I will say, MOB for mobile phone. And then I have, for each mobile phone, I will have, for example, a screen, and I'll have one screen. And then for the mobile phone itself, I will have a speaker, and let's say I'll have 3 speakers. And for the mobile phone itself, I will have a processor, and I will have 1 processor. Now for the screen, I will have, let's say, buttons, and I'll have, let's say, 2 buttons for the screen. And then for the screen as well, I will have a camera, a front-facing camera. So it's 1. So you see, I have this screen in the component, and I have it as the item, which is in here. And this is what's happening in this mapping. If we try to map it otherwise, so if I say, okay, I will just have everything listed like this. I have the item, and I have the description and cost and quantity. Now, if I just list, okay, the item is mobile phone, and the description is some kind of description, and the cost is some kind of cost, and then quantity. What is quantity? Do I have 3 phones? Let's say I just did this. Now, where is this relationship? So this says I have 3 phones that are costing some amount of dollars, but I don't see the relationship. So we cannot just map it like this. We need to map the relationship in a different relation. Now let's look at the ternary relationship case. We will start by converting the relationship into an associative entity. We will create an associative relation, obviously, for that. But in this case, remember when we had an associative entity, we had the keys of the 2 participating entity types as the primary key. Now we will have 3 participating entity types, so we'll have the 3 primary keys as a composite key. So let's look at an example. We have this example where we have physician, and we have patient, and we have treatment. Then we have the patient treatment. So this is after conversion. So it used to be something like physician, and we have patient, and we have treatment. And then we have some attributes on the relationship here for the date and time and results. So these are attributes that are going to be represented here. So this is the same thing, but we just broke this and placed the associative entity in the middle, and we got into this graph. Now the rule says we will create the associative entity or associative relation based on the associative entity, and then we will have the keys for 1, 2, 3 participating entity types as a composite primary key. So we will include all of these in here. Now in this example, it has the treatment date and treatment time as parts of the key, because this is assuming that we only have one date and one time for the treatment for each patient. So this is an assumption for this part, but this is what you need to care about. So we need to care about the 3 keys for the 3 participating entity types being primary key or parts of the composite primary key, let's say, and also being foreign keys because I don't want a patient ID in the treatment table that doesn't exist in my database. Don't want the physician ID that doesn't exist in my database, and I don't want a treatment ID that does not exist in my database. Now again, the reason for having these is I don't want to have repeated record with the same date and time. That's why they assume that I need to have at specific date, a specific time, only one treatment. And this is again an assumption from the ERD that you don't have to worry about. Now, last but not least, I want to talk about supertype and subtype relationship mapping. So the rule is to create a separate relation for the supertype and for each one of its subtypes. And then we will assign to the relation created for the supertype the attributes that are common in all the members, including the primary key. Remember, because the supertype is going to have all the common attributes, so it makes sense that the relation that is associated with the supertype is going to have the common attributes as well. Now for the subtypes, we'll assign the specific or unique attributes for that subtype. And we will assign possibly one or more attributes for the subtypes to serve as the subtype discriminator. Why did we say one or more? Because remember, if we have disjoint relationship, then it's going to be, or disjoint constraint on the relationship, it's going to be one discriminator. If we have overlap, it's going to be more than one, and then we'll have some kind of binary or Boolean attributes in there. Now this is one example where we have employee that has three types: hourly employee, salaried employee, and consultant. And the rule says we will have all of those attributes that are common to everybody in the employee relation. So I will have those here in the employee relation. And then I will have one for hourly, and one for salaried, and one for consultant. So let me just go back and forth to delete those, and this is going to be our relational model for this. Now as you see, we will not include these in the rest because these are common to them. And we included employee type in here, and then we have the IDs for those. Although we don't have an ID in hourly employee, and we don't have in salary, and we don't have in consultant, but for the relational model, the rule says every relation must have an ID. So I'll have those keys as primary keys, but then they will be foreign keys referring to the employee number, because the hourly employee number is the same employee number that should be in the employee table. Same thing for consultant, same thing for salaried employee. And I need them to be foreign keys because I don't want a fake employee number or employee ID to be entered in each one of those tables. Now finally, I just included a mapping summary that is going to summarize all the rules for mapping. So the structure is here and the rules are here. So if we have regular entity, composite attribute, multi-valued, weak entity, binary one-to-many, binary many-to-many, many-to-many, binary or unary one-to-one, so this is the same thing, and binary or unary, many-to-many, ternary, and then finally subtype, supertype relationship. So this is going to be just a summary for all the mapping that you need to transform from ERD into relational model. And again, transforming from ERD to relational model is just following the rules, nothing else, nothing more, nothing less.